In problem number 9, what you should be recognizing here is that we've got a G prime, G prime, G prime of C, and that indicates mean value theorem. Okay, so this is a mean value theorem problem. F is a differentiable function, f of 0 equals 0. So let's draw a little graph, a little kind of situation what's going on. F of 0 is 0, so we've got an x-intercept of 0, y-intercept of 0, the axes here. We also see that g of x is defined to be f of x times cosine x. Okay, and so since that's the case, what we want to do is we want to figure out what's going on these intervals, because we can see 0 to pi over 2. Let's try that one first. Okay, so if g of x is f of x times cosine x, then we're going to define g of 0 to be f of 0 times cosine 0. Okay, well f of 0 is 0, and 0 times anything, and cosine of 0 happens to be 1, but 0 times anything is just 0. Okay, or any real number I should say. So 0 is the value of g of 0. So what we're going to do now is we're going to graph or put points on the graph here that represent values of g at certain values of x. Okay, so anyway, g of 0 is 0. So maybe I'll do that in red now. So g of 0 is 0, and then we want to figure out what g of pi over 2 is, and so let's do that as well. Let's use a different color here. G of pi over 2 is f at pi over 2, and then multiplied by cosine of pi over 2. Well, we know that we don't know what f of pi over 2 is, but let's see, f is a differentiable function, so we could figure it out. If we could figure it out, it would be a real number, so we don't know what it is, but we do know that the cosine of pi over 2 happens to be 0, and 0 again times any real number is 0. Okay, so in red again, we're going to put g of pi over 2. Okay, so if you remember the mean value theorem, we could have g looking like that, g could look like this, g could look like anything. We don't really care what g looks like. We do know that, sorry, I was reading something. We do know that g is differentiable because f is differentiable, and a differentiable function times cosine, f being differentiable multiplied by cosine, it will also be differentiable. There's no values of x that would make that undefined. So therefore, since g is differentiable, we know that since the mean value theorem says that the average rate of change of the function g in between 0 and pi over 2, in this case it happens to be 0 because g of 0 is 0 and g of pi over 2 is also 0. The mean value theorem guarantees us that g prime at 0 is going to be equal to 0 somewhere in between. It doesn't matter what g prime looks like, or sorry, what g looks like, somewhere in there, it might be one time, might be more than one time, but the derivative at some point along the way is going to be equal to 0. So therefore 1 would be true. Now if we continue to duplicate what we just did, then we need to figure out what g of pi is. Okay, because there's this other interval that we're wondering about, pi over 2 to pi. So g of pi is f at pi multiplied by cosine of pi. And we know that the cosine of pi is -1, and we don't really know what f of pi is. So we're going to replace that with a question mark, and we don't really know. Now, if it happens to be 0, great, but we don't really know. So the question, which of the following statements must be true? Well, we're not sure about this one, so that doesn't necessarily have to be true. I mean, f of pi could be something other than 0, and therefore g of pi wouldn't be equal to 0. And let's look at and see what that would look like on the graph. If we put pi over here, g of pi could be somewhere like that, and so we might have it. We might have the graph of g looking like that. We're not guaranteed that we're going to get g prime equaling 0 anywhere in that interval, since g of pi is not 0. Okay, now let's go ahead and repeat that same process one more time for the interval from negative pi over 2 to 0, and all we have to do is show that g of negative pi over 2, let's use a different color again, g of negative pi over 2. You can probably see this unfolding. F at negative pi over 2, which we don't know, but multiply that by the cosine of negative pi. Let me see if I can squeeze it in there. Negative pi over 2, which we know the cosine of negative pi over 2 is 0. 0 times whatever real number is equal to 0. And so therefore, again, we get a g of the other endpoint, g of negative pi over 2 is 0. So the average rate of change of g on the interval from negative pi over 2 to 0 happens to be 0. And therefore, in between that, again, it could go up like that. It could come down like this. We're not sure what it looks like. We don't really care. But what we do care about, guys, is that somewhere along the way, because of the mean value theorem, g prime must equal the slope of the average rate of change. So g prime somewhere in there is equal to the average rate of change. And this actually is a specific example of, or I should say a special case of the mean value theorem. We call it Rolle's theorem. So when g at one endpoint is equal to g at the other endpoint, then we're guaranteed that g prime will be equal to 0. And therefore, since 1 and 3 are the only ones that are true, D is the correct answer.